Welcome to your lesson on the parameters of quadratic equations. We'll begin with a flashback. We need to talk about functions and relations. If you may remember, a relation is a set of ordered pairs. For example, we have a set of ordered pairs here. This shows a relationship. And in this case, the relation is between the number of chocolates in a box and the price of that box. So number of chocolates, price, number of chocolates, price, and so on. Relations can be represented in, so this is a set of ordered pairs. We can also represent them in tables, in graphs, in equations or as equations, and in mapping diagrams. Let's take a look at what those look like just to remind ourselves. Well, here's a table. So here we have the number of chocolates and the price. So the relation is shown in this table. Or the relation can be shown on a graph with the points plotted on there like that. Here is number of chocolates, price, and we can see all the points plotted there. These are all equally valid representations of a relation. Or we can use something that's called a mapping diagram. It looks like this, where we show the inputs here. So input, 6 chocolates in a box, 12 chocolates, 18 or 24. Outputs go in here. We know when we had, and you usually use arrows to connect. So 6 chocolates in a box produces a price of 8. That is our output. Or 12 chocolates in a box produces a price of 12. 18 chocolates produces that, 24 produces that. This is called a mapping diagram. We can say this input maps onto this output. Okay, now functions. Function is a specific type of relation where every element of the first set, which is known as the input or the independent variable, is mapped onto one and only one. That's what a function is all about. One and only one element of the second set, which is the output or dependent variable. So this last one, this was a function because every item from the input leads to only one item in the output. That's the definition of a function. All right, so let's take a look at it visually here. So a function, this is a function. Every part of the input, every input leads to only a single output. You can see there's only one place that each arrow goes. That is called one-to-one because one input produces one output. One input, one output, and so on. Things that are not functions. Oh, sorry, here's another function. This one's a little strange because all the arrows go to one place. However, each input produces only one output. Like input of 1 produces only 2. Input of 2 produces only one output, which is also 2. Input of 3 produces only one output, which is also 2. So it doesn't matter if that output is the same. Each input is producing only one output. This is called a many-to-one function because many things lead to one output, many inputs to one output. Something that is not a function, this is not. Notice here, well, we have one-to-one here. 1 leads to 3, 2 leads to 5, 3 leads to 7, but the input of 6 produces 2 outputs, 7 and 13. And that goes against the definition of a function. It's a relation, but not a function. And that is called a one-to-many. So one-to-many relations are not functions. One input leads to many outputs. Okay, something we can use to check if something's a function is called the vertical line test. It works because, well, it works like this, and we'll talk about the y in just a second. Here's a vertical line. We can move the vertical line across our data or across our graph. If the vertical line ever intersects 2 points at once or more, then the relation is not a function. Notice here, it hits those 2 points at one time. Therefore, this is not a function. Why? Because the input 1, when that vertical line hits it twice, is showing us the input of 1 produces 2 different outputs, 1 and 2. So one input produces 2 outputs. That is not a function. On this side, though, however, if you take this vertical line across this data, we can see our relation is a function. Each input produces only one output. Okay, so here's a final summary of that. This is a function. This parabola is a function. So we're working with parabolas right now. They are functions because the vertical line shows us that each input produces only one output. As you move that red line left to right, it will only hit the parabola one time everywhere. That means a certain input produces only one output. However, this parabola turned on its side is not a function. You can see the vertical line hits the function twice, here and here. That means that this input, whatever x value that is, there are 2 possible outputs. So that is not a function. All right, now let's go on from relations and functions to inverse relations and functions. Let's remind ourselves what an inverse is. So here's an original function with these data points. An inverse is written like this. We see that little -1 there. That means we're looking for an inverse. An inverse is just basically a function that's created by swapping the inputs and outputs of the original. So if this input was -5 and the output was 0, in the inverse, the input will be 0 and the output will be -5. The next one will be 1, -3, and then 2, -1, and so on. So the inputs or the x and y values are swapped. That's called an inverse. We're going to plot this one in blue. So there's the blue for this data here, -5, 0, -3, 1, and so on. Now let's plot these points in green. There they are. And we're assuming that we can connect them like that there's other points in between that work. So now we have this. What do you notice about your inverse function? Or what do you remember about inverse functions? Well, maybe you remember that inverse functions are reflections of one another across this mirror or this diagonal line with the equation y = x. This is a line that has a slope of 1 and a y-intercept of 0. There it is. And these are mirror images across that line y = x. So that's how inverses will always look. So is f of x a function, the original, the blue one? Is that a function? Does it pass the vertical line test? Is there only one output for each input? Well, of course. -3 produces 1. -2 produces whatever that is. -1 produces that. There's only one output for each input. Is the inverse also a function? Yes, it certainly is, because every input also has one output. So for a linear function, which is what this is, we'll always have a inverse that is also a function. Now it's time for a little exploration. You will need Desmos for this, but let's begin without Desmos looking at this first. We have a graph of f of x = x squared. So we have a basic parabola, x squared. You can see it here. All right. It says state the two values of x which map to f of x = 4. f of x = 4 just means y = 4. So think about it. Are there two x values that lead to y = 4 on this graph? And what are they? Okay, let's take a look. Y or f of x = 4 means y = 4. So this is y = 4 here. On the graph, we have 2 points, this point and this point, where y is 4. Y is 4 at both of those points. And what x values lead to those? Well, -2 leads to that y value of 4, and 2 also leads to this y value of 4. So there's our 2 points on this parabola that have the same y value and 2 different inputs. Now, thinking back to what we did before, is this many to one, one to many, one to one? All right, so now that means if we put 2 into this function, this is what this means. 2 goes into the function. The input is 2. Input of 2, if you put 2 in here, 2 squared means 4. It works. And if you put an input of -2, so -2 goes in here, also produces 4. And that works, right? We know that y is 4 in both cases. All right, can you find the two x values which map onto f of x = 16? So now you're thinking f of something = 16. What goes into the function to produce 16? And there should be 2 of those things, 2 x values, just like we had 2 x values producing that. All right, so x squared = 16. Well, what are you squaring? 4 can go into this function and produce 16, and also -4 can go into this function and produce 16. So at 4 and -4, which were off the graph we see here, but if you went to -4 and 4, it would lead to the same y value of 16. So now let's look at it in terms of mapping diagram. We have our inputs of -2, 2, -4, 4, and -2 and 2 in this function both led to 4. And -4 and 4 in this function both led to 16. So again, what kind of function is this? Well, it is a many-to-one function. Many things lead to one output. Many inputs lead to one output. Many inputs, one output. So parabolas are always going to be many-to-one, because there will always be many x values or 2 x values leading to each y value, because there's symmetry going on here. Okay, let's get into Desmos now, and our goal is to graph these two. We're going to graph this one, which I've already done for you here. I've graphed this first function, and the goal here is to find pairs of points that work the same way we just saw. So like here at x = 0 and x = 2, we have the same y value of -3. Or at x = -1 and x = 3, we have the same y value of -6. And the third pair of points I have here, when x is -2 or when x is 4, we have a y value of -11. There's always those two x values leading to the same y. Can you think of some pairs for this one here and list them in your answer? Graph that one in Desmos and list some pairs of points. Okay, so in our case again, we have a many to 1 because 0 and 2 both lead to -3. The inputs of -1 and 3 both lead to -6, and so on and so on. Great. Now, when we have a parabola like this, is the original a function? Think of the vertical line test. Yes, it is. It passes the vertical line test. Each input, one output. Does the original pass the horizontal line test? What is this horizontal line test? Well, imagine drawing a horizontal line. Instead of a vertical line, a horizontal line. Does that hit only once every time? No way. If you drew a horizontal line anywhere here, it would cross twice. So what does that have to do with anything? Let's check. Is the original 1 to 1? That means every input leads to one output, but also every output leads to one input. So no, it's not 1 to 1. We know it's many to 1. There are many or 2x values that lead to each y value. So it's not 1 to 1. Okay. Will the inverse be a function? No. If a function is many to 1, the inverse will not be a function. A function needs to be 1 to 1. That means only a single y value for each single x value. That's the only way you can have the inverse of it be a function. Let's see why. So we're going to graph. I took a point there and I inverted it. -4, 8, and I made it into 8, -4. I took another point, -3, 4, and I made it into 4, -3. And then another point, -2, 2. Now I made that into 2, -2. So I'm inverting the points, making inverses, right? Here's another one. 0, 4 becomes 4, 0. And 1, 8 becomes 8, 1. So now I've created the inverse. There's my inverse function. You can see it clearly is a reflection over the line y equals x. So it's definitely an inverse. That's how inverses work. So now, is this inverse a function? We can see clearly it is not. If you drew a vertical line, it would hit twice. So the original is a function. The inverse is not. Because, and that's why we did the horizontal line test. If you took a horizontal line here, it's the same thing as checking a vertical line here. So a horizontal line on the original is like a vertical line on the inverse. So horizontal test here tells us if the inverse will be a function or not, and it's not a function. So you must have 1 to 1. Remember that. Key point. Many to 1 functions do not have inverses. Well, they have inverses, but they don't have inverses that are functions. So therefore, parabolas, which we're always working with, will have inverses, but they will not be functions. All right, let's talk about graphing quadratics a little bit more to wrap things up today. And when we graph quadratics, the result is called a parabola. Pedro, okay, hizo. Ele fala por parábolas. Ooh, okay, that's a good joke. All right, here's a problem. These are your x-intercepts. This is a y-intercept. This is your vertex. This is the axis of symmetry. And this one is said to be concave up because it opens up, and therefore its vertex is a minimum point. Next one, here's another parabola going the other way. We still have a vertex, we still have two x-intercepts here, we still have a y-intercept, and we have a line of symmetry here. This parabola opens down, therefore it is concave down, and therefore the vertex is a maximum point. Okay, with that in mind, we have been looking at standard form quadratics. The coefficients do something in a standard form quadratic. They do something very important. So I'm going to pause here, end this video here, and there's a part 2 which you must watch. It's going to be a very short part 2, but the part 2 is going to have you investigate just a little bit into what happens when the coefficients a, b, and c are changed. These coefficients a, b, and c here in a parabola, they affect the shape of the graph, and they affect it in really important ways when we change these values. These values, by the way, are called parameters. So in the next video, which you will watch right after ending this one, you will see a little bit about what those parameters do to our parabola. See you soon.